Okay, 13.7 is graphing trig functions. We're going to start with sine and cosine, and then make another video for a tangent later. Graphing cosine functions, and our x value, our variable, now stands for an angle. Usually when you graph functions, x is the independent variable and can represent really anything. In these cases, it represents the angle of a function specifically. So if you think about a unit circle, as the angle theta changes, so when you start your angles here, you're at 0 degrees, and it increases. But if I'm measuring cosine of theta, cosine really means the x-coordinate. So I think about this distance here, this distance right here on the horizontal axis. And as the angle of theta increases, the horizontal distance keeps on shortening and shortening to where it was, it was here at about, well, it was at a half right here. But then as this moves, it gets shorter and shorter and shorter to where the distance keeps on getting smaller. So as that happens, as the angle of cosine increases, the horizontal distance moves from 1 all the way down to just 0 when you're right here on the y-axis. Then as that angle theta keeps increasing, as we go from 90, now the horizontal distance keeps on increasing. And as the horizontal distance increases, you end up all the way out at 1. And this horizontal distance, really it's -1 if you think about direction. It goes as far as having a greatest x value of 1 and a least x value of -1 with everything in between. And pretty soon, as that angle theta just keeps on going around and around, you get smaller, bigger, smaller, bigger, and your distances just keep on oscillating back and forth. So let me see if I can show you how this works in a graph. Our x variable is really theta, and our input is theta, and our output is the horizontal distance. Well, if our theta is 0 degrees, the cosine at 0 degrees, right here, is 1. If our theta is 90 degrees, the cosine at 90 degrees is 0. The horizontal distance there is 0. If cosine is at 180, I'm just going to count by 90s. If cosine is here, then we're at -1. At 270, we're all the way back down to 0. The cosine at 270 is 0. And once we've gone all the way around to 360, we're back at 1 because the cosine of 360 is again 1. And that means if I keep going, 450 is going to be the same as 90 because they are coterminal angles. They end at the same point. And 540 would be the same as 180 because they're coterminal. They end at the same point. So this is just going to keep on going around and around, over and over and over. It makes the graphing rather simple. I'm going to jump to one screen now. I'm going to count starting at 0 and just go to 90, 180, 270, 360. And here I'll put 1, and here I'll put -1. I like to just give some space to have room to work with this. Well, I start at the point 0, 1. That was my first coordinate here, 0, 1. And then I have the point 90, 0, 180, -1, 270, 0, 361, 450, 0, 540, -1. Oops, -1 would be here. And that's actually just going to keep this pattern, so I go from high, middle, low, middle, high, middle, low. And it just keeps on going -1, 0, 1, up and down. Oops, I didn't do that one very well, so I'll try that again. Up. Don't draw these as straight lines, draw them as little curves. Up, down, up, down, up, down, up, down, up, down, up, down. And there is a sine wave. In fact, if I go to my calculator and go to my y equals menu, and I just froze everything, so maybe I'll try and fix that later. But if I could pull up my calculator and do it on my sine equals menu, heck, I will. Okay, I'm back. I'll turn it on. I'll go to y equals, and I'll type in the cosine of x. And I'll make sure that my mode is in degrees. And instead of having my window go from -10 to 10 like usual, I want to go from like -540 to 540 and count by 90s, because that's how big my scale really is. My y's can go from -2 to 2 and count by 1s. And you'll see it makes that sine wave. And that sine wave repeats forever and ever and ever on to infinity. If I wanted to take this and graph it, I just graphed it in degrees. If I wanted to graph it in radians, I would play the same game, only every place where I had degrees, I'll make my table this way now, every place where I had degrees, I can do theta or x, I would now have radians. So I used to have 0, 90, 180, 270, 360, but now I have 0, pi over 2 radians, 3 pi over 2 radians, 2 pi radians, and it goes 1, 0, negative 1, 0, 1. And I'll just graph this the same way. So 0, 1 pi over 2, 2 pi over 2 are just pi, 3 pi over 2, 4 pi over 2 is 2 pi, there's 3 pi, negative 2 pi, negative 3 pi. And I go 1 to negative 1, and I start 1, 0, negative 1, 0, 1, 0, negative 1, and here's the same curve, just graphed in radians now instead of in degrees. And for the record, in the calculator, I would just take my mode, switch it from degrees to radians, and take my window. Instead of going to negative 540, go to negative 3 pi. It's going to be a little bit further than it was last time, but that's fine, because this is more than, the calculator shows it as a decimal, but it knows you've typed in 3 pi, and I'll count by pi over 2's. And there's the graph. Wonderful. Let's talk about sine now. Sine is actually easier to understand, I think, because you're dealing with vertical distances as opposed to horizontal distances. So I'll go back to my split screen here. Now with sine, you're looking at y values, not x values. So you're looking at the heights of things, looking at all these y values as you go around. The sine at 0 degrees is 0. So if I plug in a 0 for theta, I get a 0 for y. And as the theta increases, as the angle increases, the graph goes higher and higher and higher. And so it goes all the way up to 1 before it starts coming back down to 0. And I hope now you see it's going to do the same thing that cosine did. At 270, it's going to be negative 1, and at 360, it's going to be 0, and it's just going to keep going around. So I'll graph this the same way. I'll go 0, 90, 180, 270, 360, 450, 540. And then negative 90, negative 180, negative 270, negative 360, negative 450, negative 540. Sine starts in the middle. The sine of 0 is 0. And then it goes 90, 1, 180, 0, 270, negative 1, 360, 0, 451, 540, 0, and back. And it's going to graph. Again, don't make these angles. Don't go like point. It doesn't do that. Give it some curves to it. Had I wanted to do this in degrees, in radians, literally all I have to do is take these degrees and make them radians. So I'm really counting by pi over 2's at this point, and 3 pi over 2. So this would be negative pi, negative 2 pi, negative 3 pi. So there's your sine and cosine graphs. Those are your parent functions, as simple and basic as they can get. Like I said, we'll do tangent some other time. Here's the formula for sine and cosine. It's y equals a sine b theta, or a sine bx, same thing. A stands for your amplitude. Amplitude is how high up or down a graph goes from the middle. Wavelength is top to bottom, but we're going to deal with amplitude. Amplitude is from the middle, which is here, to the top. How far do you go? So in this case, the amplitude was 1. The wavelength would be 2, but we don't deal with that. The amplitude is 1. And the b value is not your period. The b value is how you find your period. So your b value requires some math to use to find your period. You do 360 divided by b if you're doing degrees, and 2 pi divided by b if you're doing radians. So let's just graph another one here. Y equals 2 sine theta. The a value is 1, which means that the amplitude is 1. So from the middle, I'm going to go up 1 and down 1. But the b value is 2, so that means that the period is 360 over 2, which is 180. What that means, what's really happening if you think about the unit circle is, every time I increase by theta, meaning by some angle, like say I increase by 45 degrees, well, because there's this 2 in front of it, because it's a 2 theta, every time I think about increasing by 45 degrees, I'm really increasing by 90, because it gets doubled. And so if I thought I was going to increase by, say, 120 degrees, if I plug in a 120 for theta, it really becomes a 240, because it goes twice as far. So all of these theta values is basically growing twice as fast. Since it's growing twice as fast, it means it goes through a cycle twice as fast, which means a period happens twice as fast, or it's half as long, if that makes any sense. The period is now 180 instead of 360, because we go around a whole circle in twice the time, or half the time, because we're going twice as fast. So if my theta is 0, the sine of 0 is 0, and then I wouldn't plug in a 90, I'd plug in a 45, because 2 times 45 gets me 90, and the sine at 90 is 1. So I'd plug in a 90, because 2 times 90 is 180, and the sine of 180 is 0. So I'm counting by 45s, 135, negative 1, 180, 0, 225, 1. You get the idea. So I'm going to go 1, 2, 3, 4, 5, 6, and just push these out for a while. Count by 45, so here's 90, here's 180, here's 270, negative 90, negative 180. Oops, I'm sorry, I'm counting by 45, so those hashes are coming too soon. Negative 90, negative 180, negative 270. And let's just plot down our points now. I have the point 0, 0, 45, 1, 90, 0, 135, negative 1. These just go high, middle, low, middle, high, middle, low. So here it's high, middle, high, middle, low, middle. And it kind of forms this triangular pattern when you first look at it. But don't graph it like it's a triangle. Put some care into making these actual curves. And it kind of fell apart there at the end. I think I can do a little bit better. There, that's much better. There's the sine of 2 theta. Okay, I'll do one more. 2 sine 5x. Well, my amplitude is now 2. My period is now 1/8 or 360 divided by 5. And 360 divided by 5 is 72. So my period is now 72 degrees. This is the last one, yeah. So what I do, and this is the best way to approach these, is I know that the whole cycle takes 5 hashes. We have 1, 2, 3, 4, 5 points. So from the middle, I go 1, 2, 3, 4, 5. And I don't even worry about the scale. I just put down 5 marks. I mean, here it took 1, 2, 3, 4, 5 numbers for us to get a whole period. It's always going to be 5. So I put 5 hashes starting at the middle. And then I think, okay, I know the very last one, my period ends at 72. So halfway of that is going to be 36, and half of that is going to be 18. So I'm going to be counting by 18s, really. I go 0, 18, 36, 54, 72. I'll erase these little dashes. They don't look like they're negatives. And so here's going to be my 54, then 72, then 90, then 108. And I think about sine. Sine starts at 0 and is immediately going up. I'm going to go all the way up to 2 this time, so 2's up here. So I start at 0, but I immediately go up to 2, and then down, and I go back to the middle, and then down, and then middle, and then up, and then middle. And I'm going to go high, middle, low, middle, high, middle, low, middle. And this sine wave is much taller. It's twice as tall. And there's my sine wave, amplitude of 2, period of 72, so each major point is at every 18 units. I'm counting by 18 degrees. If I want to do this in radians, I sure could. In radians, I wouldn't do 360 over 5, I'd do 2 pi over 5. So this measure right here that was 72 is now 2 pi over 5. And I would take that and I'd cut that in half to get this one. So 2 pi over 5 would become, cut that in half, it's 2 pi over 10, which is actually pi over 5. I cut that in half, and this would be pi over 10. So I'm counting by pi over 10s. Pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, 5 pi over 10, 6 pi over 10. You can do it in radians just by taking your degrees and converting them to radians. Finally, here we have a graph that I have the graph, and I want to know what's its equation. This is the last thing we'll deal with in this video. The thing you want to check first is, are you starting at 0, 0 or at 0 something? If you're starting at 0, 0, you're doing a cosine graph. But if you're starting at 0 something, you're doing a sine graph. And since this... No, I'm sorry, I have that backwards. Let me fix that right now. If you're starting at 0, 0, that is sine, because the sine of 0 is 0. But if you're starting at 0 something, that's cosine, because the cosine of 0 is 1. Since this starts at 0 comma something, I know it's a cosine graph. So now I've got to find A and B. Well, the amplitude is 2. From the middle to the top, I'm traveling 2 units, so the amplitude is 2. Then I've got to find B. The period from here, from this point here to this point here, we travel 120 units. This distance here is 120. So my period is 120. We know that B, that 360 over B gives us our period, which is 120, so B must be 3. So this is the equation, y equals 2 times the cosine of 3 theta. Amplitudes and periods is all we deal with today. Later on we'll talk about translating these things around, but I want to quickly show this little thing that I've made up that shows you a sine wave. What's going to happen here is this point is going to get moved around, and as it gets moved around, the vertical distance here is going to get traced. It gets traced up and traced down, and you'll kind of see it follow along this curve here, I think. So let's just press play and see what happens. Yeah, see, as it goes around, it goes up and down, up and down, up and down, and it keeps on tracking that height of the graph back and forth. I can even do it backwards. We're doing it backwards now, but it's saying as the y value here gets higher and higher and higher and lower and lower and lower, the graph goes up and down and up and down, and you can kind of see that curve going back and forth. So now we're moving in the positive direction. The angle of theta is getting bigger and bigger, but it keeps cycling up and down and up and down, and that's why it's called a circular function. I hope that is helpful. Have a wonderful